Hi, Assalamualaikum warahmatullahi wabarakatuh to our lecturer, Dr. Jamaluddin, and to my fellow friends. Today, we're going to present about robotic system, which is Microbit baseline follower robot. Before start, I'm going to introduce our team. First is Bai Jordan, second is Muhammad Fikri, third is Khairulanwar, fourth is Iman, Nuraina, and last, me, myself, Putri, Zalia. I'm going to present about introduction. So, firstly, about problem statement, traditional line follower robots are widely used and very simple. These robots follow a pre-programmed course and are enabled to adjust to changing conditions or find the best routes in the real time. The performance is greatly impacted by this constraint, especially in application that needs a high degree of accuracy and efficiency. Second is problem solving. Developing a queue-follower robot that can independently choose the shortest path to its goals while navigating is complicated. Make sure the robot can process real-time sensor data and dynamically modify its course to reduce trip distance and increase overall operating efficiency is the difficult part. Lastly, as better result. The goal of creating and putting into the practice sophisticated decision-making algorithms for line follow robots is to significantly increase their accuracy and efficiency during navigation. So the robot will be able to complete tasks more quickly and with a less energy use. So I'm going to pass to our next members.
Okay, hello, my name is Muhammad Zulkifli. So right now I will go to the literature review. First point about the mechanization in the modern industry. The first phase of mechanization was initiated during industrial revolution, which used the steam engine and mechanized tools to the manual works. They introduced the application of the robotic in industrial facilities, also known as the industry point 4.0, have brought out smart integrated system that can optimize and control themselves from a distance. Another major shift in contemporary mechanization has been integration of self-governed vehicles in the areas of the storage and transport. Next, we go to the application of the robotic in the industrial and residential settings. Robots are used in industrial to increase the productivity and accuracy while reducing risk in the operation within industries. Such operations include the production, material handling, inspection, and transportation or delivery. Many industrial robots are integrated with a sensor and artificial intelligence which help them to complete specific tasks more accurately and efficiently. Now we go to mechatronic engineering and its role in the autonomous system. Autonomous systems are developed based on the field of mechatronic engineering, which is a combination of the mechanical engineering, electronic, control engineering, and computer science. Another field where mechanical engineering is applied to autonomous system is in the car manufacturing, in the production of self-driving cars. Mechatronic systems in industrial automation are in form of the robotic arms, floor lines, and the accurate machinery. Next, we go to the fundamental of embedded system designed for robotics. A mechanism play an integral role in the functionality and execution of the robot system through the concept known as embedded system design. Basic element of embedded system are the microcontroller or microprocessor, the memory and the input-output port and the software. The principle of the embedded system design for robotics involved a variety of disciplines, including communication protocols, software development, hardware selection, sensor actuator integration, and power management. That's all for literature review. Thank you.
Hello, my name is Jordan Wilfred, and my matrix number is CE 10035, and today I will be explaining the code that we use for the line following robot. Basically, there is a 5 IR sensor that is used to detect the line, and each of the 5 sensors is assigned into a pin, such as this pin 2, pin 1, 9, 0, and 12. So each corresponding pin detected low, which is for the black line, will do a function such as forward, slide left, slide right, sharp right, and else it will reverse. Okay, so let's go into the function over here, such as forward on pin 2. Pin 2 is the center of the IR sensor, and if we go to the forward function, we can see that the robot will move forward in a speed of 200 with a basic pulse of 50 milliseconds. And if the digital pin 1, which is the sensor number 2, return 0, it will turn slide left. And you can see over here, slide left, the left motor M1 will run backward in speed 150, and the M3, which is the right motor, will go forward. Next is P9. P9 is for the IR sensor number 4, and it will turn slide right, which is M1 motor left will move forward 255, which is the full speed, and M3, the right motor, will run backward with a speed of 150. So next is the IR sensor for the first sensor on the left side, pin 0. If it is return 0, it will perform sharp left function. And if we go to the function, you can see that the left motor M1 will move backward at the speed of 150. Right motor forward to 55. That means it will sharply turn on the left. Next is the most right IR sensor, which is connected to pin 12. If it is written 0, it will make this function, which is sharp right. And in the sharp right, you can see that the M1 will move forward at the speed of 255. Left M3 motor will move backward at the speed of 150. And else it will reverse. Reverse is over here, where both of the motor will run backwards at the speed of 200. So that is all for the explanation of the code, and next we will see the result based on this algorithm that we implement.
Okay, my name is Khairulanwar, bin Iskandar Hayat Mubarak. Today I will present the result for this project. Okay, as we know, the robot has a microcontroller and have many pins, and we use the pin number 2 for the digital read of center IR sensor is height that will result in both motor of left and right to be 78% or 200 speed based on the 0 until 255 PWM setup. This is the straight line robot movement. Okay, next is a 90-degree turns. Approach 90 degree of right turn the robot IR sensor number 4 and 5 return height, indicating the need for a rightward adjustment and execution of the function sharp right and slide right function respectively. This is 90-degree robot turns movement. Next is a 45-degree turns. Slide 45-degree turns only return height for the IR sensor number 3. The left motor M1 continues forward while the right motor M3 adjusts also by reversing slightly to initiate the turns. Okay, next is a U-turn. Performing U-turn movement for the robot is executed smoothly where IR sensor number 1 and 2 return height. Left motor M1 to be slightly reversed and right motor M3 to continue forward. next result is a performance matrix analysis. We separate to three performance. Firstly is accuracy and line following behavior. The second performance is speed and response to line variation. And the third is the sensor effectiveness. Okay, for the accuracy and line following, the robot show an average accuracy of 95% by counting the number of slight deviation from the line path, where the deviation is still present on the straight line in each trade. And for the speed and response to line variation, the robot speed during the line following was observed to remain relatively consistent across different sections of the path, which is at 75% speeds. And for the lastly, sensor effectiveness in well-lit environment with consistent black line contrast, the sensor operates with high accuracy, detecting the line promptly and enabling precise navigation. Okay, for the next result is challenge faced during execution and setup. There are two challenges that we get from this project. First is environmental factor, and the second is algorithm adjustment. Okay, for the environment factors, the flat surface texture significantly influence the robot performance, where the surface of the track with slight wrinkle influence the robot performance, making the traction of the robot to be decreased. For the second challenge is algorithmic adjustment. Through the testing phase, iterative adjustment were made to the line following algorithm to enhance the robot's behavior and performance.
Hello and Assalamualaikum. My name is Iman Nuraina binti Rosaimi. My metric number CE210088. So I will continue for the last part, which is conclusion. So the project aimed to develop and evaluate a microbit based on the line following robot and capable autonomously navigating predefined paths marked by contrasting black line. Next, the environmental factors such as flow texture, lighting variation, and change in the line color significantly influence the robot performance. For the improvement of robot, additional sensors should be integrated, such as ultrasonic sensor, to provide an additional perception of the robot surrounding. And lastly is the project underscore flexibility and potential using low-cost microbit for educational and prototyping purpose in robotic in terms of robot implementation and robot movement algorithm. So that's all for me. Thank you.